All right, so first question we're going to take a look at is for a parabola. For each conic section, I will give you one of three things. I'll either give you the picture, I'll give you information about it, or I'll give you the equation. So we'll do one of each type for each conic. Okay, we'll pick one type. So the type we're going to do for the parabola is where I give you some information about it, and then you have to give me the equation. All right, so first thing we got to do is figure out the equation that we're going to use. How many different ways can a parabola open?
Down.
Yeah, there's 4 ways. So we got to figure out which way this one is opening. And the easiest way to do that is to graph your vertex and focus. And remember that the parabola wraps around the focus. Okay, so my vertex is at 3, -1. My focus is at 3, +1. And the parabola has to go from the vertex and wrap around the focus. So which way would the parabola have to open?
Up.
Yep, so that has to open up. So looking at something like that. And what's the right-hand side of the equation for opening up? Don't worry about shifting it yet, just the basic equation.
4/8y.
Right, positive y direction. Positive 4, and you put the y there, and that'll make it open up. And what would go on the other side?
X.
Yep, parabola is the only conic section where one variable is squared and the other one is not. Now, we've shifted. When we shift it, the vertex in a parabola is HK. Which letter is the H going to be in parentheses with? The X or the Y?
X.
Yep, goes in parentheses with the X. So X minus H squared equals 4A, and then the K goes in parentheses with the Y. All right. So now, if we don't know these yet, we should write them down. A, H, and K. And what is A going to be in this case? 2. A is the distance between the vertex and the focus. So A is 2. Okay, H, well, we've got it labeled right up there as 3. And K is -1. So fill everything in, and then that's our answer. So Bruce, what's going to be on the left side?
The left side's going to have the I don't know.
How about Xavier? Do you know what's going to be on the left side?
X minus 3 squared.
So yep, X minus, we're just going to fill in 3 for H. And we know A is 2. So Chloe, what's 4A going to be? 8. And then in parentheses after the 8,
Y plus 1.
Y, and that's going to change to a +1. Yep. And that's it. That's the equation of your parabola that meets the conditions up above. Now, that's our final answer. But let's say that we were doing a different problem, okay? Totally different. And you ended up with somehow this as the final answer. Let's say x squared equals 12y. And that's what you got when you did it. If they asked you to get the y by itself, what would you do on both sides?
Divided by 12.
You would divide by 12. So it is possible that on the test, you get an answer like this. And if it's multiple choice, I might write it like that. Okay, so you may have to manipulate your answer by moving something from one side to the other. In a problem like the one up above, I probably wouldn't have you do that. Okay, but in one like that, I might. Any question on that one? Okay. Okay. All right, so the next one, we're going to be working with an ellipse. We're going to find the equation of it. And we have to remember that there's how many different types of ellipses? How many different equations are there? Two, right? Parabolas have 4, ellipses only have 2. You either have the horizontal axis, you either have the major axis horizontal or you have the major axis vertical. Which way does the major axis go in this one?
Horizontal.
It's horizontal. So we need to come up with the equation of an ellipse with the center. Where's the center here?
0, 0.
At the origin. So center at the origin, major axis is horizontal. Okay, so first of all, what is the equation always equal to for a number?
1.
It's always equal to 1. Okay, we're going to have 2 fractions. What symbol goes between the 2 fractions for an ellipse?
Plus.
It's a plus sign. And for an ellipse, what we got to figure out our numerators and our denominators. What letter do we always put first in the numerator for an ellipse?
X squared.
Yep, we always do the x squared and the y squared. And now we know a is greater than b, b is greater than 0. So you have to figure out where the a and the b, a squared and b squared are going to go. Where's the a squared going to go? Under x or under y?
Under X.
Right. We have to put it under the x because we want the major axis to go in the x direction. So we put a squared here, b squared there. All right. Now we just have to identify a and b. Okay. What is a in this case?
3.
3. A is the distance from the center to the vertex. All right. What about b?
1.
1. B is the center to the minor axis. And we don't need C, but you should know how to find it because I may give you a picture and say, tell me what the focus is. Okay, the focus is not marked in that picture, but you can find it.
I think the focus was marked in that picture being inside of the circle.
Yep, the foci would be somewhere inside the circle,
Okay.
in the ellipse. That's right, the ellipse. What's the formula to find C if you know A and B?
Is it c squared equals a squared plus b squared?
C squared equals
A squared minus c squared.
minus B squared. Yep.
Which one is it plus?
That's for a hyperbola. Yeah. So C squared equals A squared minus B squared. So in this case, C squared would equal 9 minus 1. So what is C?
2 square root of 2.
Yep, it's the square root of 8, which is 2 root 2. Again, you do not need C to do what I asked you to do in the problem. But there will be something on the test where a different question than this one, where you do need to find the C value. That's why I practice. All right, so let's write our equation. So we have x squared over 9 plus y squared over 1 equals 1. That's the equation.
Wait, give us an equation where the n will be like a number not 1 and then you have to divide it.
You could have one where you do have to divide through to make it a 1, like we did in the notes. Yeah, you could have one like that. Now, if you check what 2 square roots of 2 is, since it's inside the ellipse, you know that it has to be less than what number?
1.
Well, remember the vertices are going to be horizontal.
Oh, 3.
Has to be less than 3. And it is. It's 2.8. So the 2 foci would be inside, like right about here and over there. The more elongated your ellipse gets, the closer the foci start to move to the outside. The more circular your ellipse gets, that's when the foci start to move towards each other. Okay, so any question on finding the equation of an ellipse? Okay. Okay, so the next question we're going to look at is describing the hyperbola. So this is the kind of question where I give you the equation, and then you give me all the characteristics about it. First thing you always want to do is identify your letters. All right, let's start with A. Okay, what's A in this case?
Or is it 3?
3.
Yeah, when you're dealing with a hyperbola, the A and the B never switch places. A is always
When
first.
does it ever switch places?
No, not for hyperbola. For an ellipse, A and B switch places. For a hyperbola, they don't. So A is the square root of the first number. How about B?
4.
4 is the square root of the second number. And then C. What's our formula to find C for a hyperbola? Yep.
C squared is equal to A squared plus B squared.
All right, so C squared equals 9 plus 16. So what is C going to be? Yeah.
5.
Yep, C is going to be 5. Usually C doesn't come out to a nice number. We would leave it as a square root if it didn't. Right, but it did. All right. What about H?
Positive 3.
It's the number that comes after the minus sign with the X. And what about K?
Negative 2.
The number that comes after the minus sign, you think of it as like y minus minus 2. All right, so now we've got all the letters we need. Let's write down the characteristics. Okay, where is the center of this hyperbola?
3 negative 2.
3, -2. Okay, which way does the transverse axis go?
Is it vertical? How do you figure that out for this one? Because I know how to do it for the.
Yeah, vertical because the B is larger.
Is that wrong?
Yeah. So
But like,
Yes.
A is smaller.
you don't look at the size of A and B to figure out the direction of the transverse axis.
How do you do it?
You look at the letter that's positive.
They're both positive, aren't
X is
they?
positive. So it's-
Y is negative because it has a
Oh.
negative in front of it.
Okay.
So the X is the positive letter, which means the transverse axis is horizontal.
What would it look like if it was vertical?
The X and the Y would switch places.
Okay.
Yep. So the X and the Y can switch places in the hyperbola. In the ellipse, they don't.
I thought it was always X and then Y is the next one.
No, not for hyperbolas. X can come first or Y can come first. That's how the transverse axis changes.
Would you give that to us, or would we have to figure that out?
Figure what? The equation?
Whether Y comes first or X?
Oh yeah, that's something you'll have to figure out.
How would we figure that out?
I would have to give you either a picture, and then you tell me the equation from the picture, or I would give you some characteristics like that, and you tell me the equation from that.
Okay.
So you could have this type of problem with a parabola, an ellipse, or a hyperbola. You could have this type of problem with a parabola, ellipse, or hyperbola. And then you could have this type of problem with a parabola, ellipse, and hyperbola. And when I say you could, I mean you will. You will have each type of these questions with each conic section. Yeah. We could do one more conic section if there's another combination you want to see, like with this information and then this conic section. So we got the center, we got the transverse axis. What else do we need to identify?
The
Vertices. Okay. How many units away from the center are the vertices?
3.
3. And they are 3 units which way from the center?
left and right.
Left and right, horizontal. What would be the coordinate 3 units to the left of the center?
0.
0,
Negative 2.
-2. What would be the coordinate 3 units to the right of the center?
6, -2.
6, -2. Okay, you get the vertices. What is another important?
Foci.
Yep. So foci. Okay, how many units away from the center are the foci?
5.
5. What's 5 units left of center?
Negative 2.
And 5 units right of center?
8, -2.
8, -2. And with hyperbolas, there is one more thing that we need to write down. The asymptotes. Okay, to write the asymptotes, we need 2 things. We need to know a point that the asymptote goes through, and we need the slope. Let's start with the point. What's the point that the asymptote is going to go through?
3, 2.
3, -2. Asymptotes always go right through the center. So we have a point. When our transverse axis is horizontal, what's the formula for the slope?
Y plus or minus B over A.
It's going to be B over A for your slope. Yep. So what we're going to do is we're going to write the equations, but we're going to use point slope form. Okay, because it's not at the origin, so we got to use point slope. So remember point slope, y minus y1, m times x minus x1. Okay, so y minus, or actually you tell me, what's going to be?
Plus 2.
It's going to be y plus 2 equals, now we have 2 slopes, positive or negative, because there's 2 asymptotes. What are my slopes? 4, positive or negative, 4 over 3. And what's going to come next?
X minus 3.
X minus 3. Yep. That is the equation of the asymptotes in point slope form. If you wanted to convert it to slope intercept form, you could distribute out the 4/3 and then subtract the 2. And then distribute the negative 4/3 and subtract the 2. But I'm going to leave it in point slope. All right, so any questions on all of that?
Do we ever do the actual equation? Oh wait, they gave us the actual equation.
Yep, this is the one where I gave you the equation. Yep. All right, so we're gonna do one more type of conic section question. So we'll go back to the parabola, but this time, instead of giving you information about it, I'm gonna give you its equation. All right, what are the 3 letters that we need to identify with a parabola?
Vertex.
Well, that's a characteristic we have to describe, but what's the letter?
H, K, and A.
Yep. So we need H, K, and A. Let's start with H and K. What is H going to be in this case?
3. Oh, wait, no. -1.
Right. H is always paired up with the X, K is always paired up with the Y. So look for the number after the minus sign. X minus -1. Okay, what about K?
3.
K is 3. And what about A?
3.
Yeah, A, because it's going to be, you have to think of that right-hand side as 4 times something. The something is your A. So just a coincidence that they're both 3. But that could happen, so we should try a problem like that. Okay, so we have all the letters we need. What's the first thing that we could describe about the parabola?
Vertex.
Okay, we could do the vertex. What's the vertex here?
-1, 3.
-1, 3. Okay, what's another thing we could describe about the parabola?
The directrix.
Okay, we could do the directrix. Which way does the directrix go? Is it horizontal or is it vertical?
Vertical.
Yes, it is vertical. If you're not sure why it's vertical, I would figure out which way the parabola opens first. Okay, let's actually write that one first. Which way does this parabola open?
Right.
It opens to the right, positive x. It opens in the positive direction. Positive. So if it opens to the right, your directrix has to be vertical. All right. How do you write the equation of a vertical line? How does it start?
Y equals.
Y equals would be horizontal.
X equals.
X equals. All right. So now we've got the vertex. Okay, it's at -1, 3. So left 1, up 3. Okay, so there's our vertex. We have to figure out where the directrix is. Do we have, let's see.
Isn't it just -4, 3?
Do we need to focus before we find the
Oh, yeah.
directrix?
Yeah, you might, I'm not sure. All right, how could we figure out, let's see.
Wouldn't it be 2, 3 is the focus?
Why would it be 2, 3?
Because, I don't know, I guess.
So I'm trying to see if we have enough information to figure out the focus. Yeah, so the focus here would be 2, 3, because A is 3. So that tells us the distance between the center and the focus, and it has to be horizontal. So if we go 3 units over, 1, 2, 3, we would end up at 2, 3. Yep. Let's write that down. So focus is at 2, 3. So how many units away from the vertex is the directrix?
3.
That's also 3. We're at -1. If we go over to here,
-4.
we're at -4. So the equation of your directrix is x equals -4. And those would be the 4 things I would ask you about for a parabola. All right. Any question on? All right, so this is a problem where I'm asking you to determine the solution to the system. We talked about what it means visually when you're finding the solution. So when you graph 2 lines, the solution to the system is where?
The points in between.
The intersection. Yep, it's where they cross. So if you had to estimate what you think the solution is looking at those 2 lines, what coordinate would you say they cross at?
1, 5.
Yeah, good job.
You already said that.
1, 5. So that's all you have to do for that kind of problem. Use the graph that's already made for you and just tell me where they cross.
That's it.
Yeah, the point will be pretty easy to tell. It's not going to be like, it's not going to be a point like here that's in the middle and you can't really tell what it is.
Okay.
There'll be nice numbers for it. Okay, so that's one kind of question on solving systems. All right, so this one is about solving a 3-variable system. So the first thing we have to do is let's number these equations. And we have to choose what letter we want to eliminate. I see lots of options here. So what letter do you want to try to eliminate? Yeah?
Z.
Want to eliminate Z. Okay. We need to pick 2 equations, and we're going to try to combine them together in a way to get rid of Z. Which 2 equations do you want to start with?
Let's do 1 and 3.
1 and 3?
Yeah, 1 and 3.
Okay. So we're going to use 1 and 3, and we're going to eliminate Z. let's copy that down. So x plus y plus z equals 3. And equation 3, x minus 2y minus 5z equals 1. All right, and you said we're eliminating z?
If you want.
Okay,
Or-
well, you said to. That's what we're doing.
Okay.
All right, so now we're going to get rid of z. What would we have to multiply by to make the z's cancel? Yeah?
The top by 5.
Okay, top by 5. All right, if we multiply the top by 5, what do we get?
5x plus 5y plus 5z is equal to 15.
15. And what about the bottom?
Just the same thing.
Same thing. X minus 2y minus 5z equals 1. And then add them up. 5x and x gives me
6x.
6x. 5y minus 2y,
3y.
3y. And 5z minus 5z,
0.
gone. And 5 plus 1,
16.
16. Okay. So we're going to call that equation 4. So we'll come back to it. We need another equation derived from that system that just has an x and a y. All right, so we used 1 and 3 to eliminate z. What do we want to use this time? Sure, we could use 1 and 2. So now use 1 and 2 to eliminate z. All right, so 1 is x plus y plus z equals 3. 2 is 3x plus 2y plus z. Equals, what was it equal to? 3. All right. What are we going to multiply by to make the z's cancel?
Yeah, you can multiply the first one by -1.
Yep, we could do the top one by -1. Let's distribute that out. Okay, Xavier, what do you get in the top?
Negative x minus y minus z equals -3.
Good,
And then the bottom equation stays the same.
stays the same. 2y plus z equals 3.
The z's cancel out.
Z's cancel.
You get 2x, 1y, and 0 for the combined 3's.
Okay, so that is our second equation. That's another equation that doesn't have an x and a y in it. We'll call that equation 5.
Wait, is it like, how can we still use it? Is it's like, isn't it like a no solution?
No, not necessarily.
When would it become a no solution?
We wouldn't know that until we get all the variables canceled out all of a sudden. Yeah. All right, so now we got to use 4 and 5. What letter do you want to try to eliminate with equations 4 and 5?
Y.
Okay, so we're going to use 4 and 5 to eliminate y. Okay, so 6x plus 3y equals 16. 2x plus y equals 0. How would you eliminate y?
You would multiply the bottom one by -3.
Okay, bottom by -3. Top is going to basically do what?
Stay the same.
Stay the same. Okay. What about the bottom?
Negative 6x minus 3y equals 0.
Negative 6x
Minus 3y
minus 3y.
equals 0.
All right. So what's going to happen here?
It's gonna cancel everything out.
Yeah, so the x is canceled, the y is canceled. And 16 plus 0?
16. For the entire thing?
Yeah, so then that, as long as we didn't make any mistakes, that would mean that it is a no solution.
Even if we made it 2x equals y somehow?
Yeah, it would still equal to 0, you know, and
Doesn't matter if you solve it a different way, as long as we did everything right, it would still be no solution.
what would an infinite solution look like?
You get the same number on both sides, like 0 equals 0.
Ah, okay.
Yeah.
Makes sense.
So in this one, we did end up with a no solution. So everything we did was right. The only thing that would have happened at this last step, had we had a solution, we would have been able to solve for x or y. Then we would have gotten that answer, and we would have plugged it back into one of the other equations to get the second letter, and then we would have plugged both of those back in to get the third letter. But in this case, this is a no solution system. Yep.